Sorry for the multiple interruptions. Apparently I am very popular today. So let's get back to this, okay? So remember, we're looking at these weird ones here. So we've got the integral of t squared plus 2 over t squared dt. So the variable, don't let it bother you, okay? Still gonna do the same thing. Now, here we've got a division problem. And what we're thinking is if we were taking the derivative, we would be thinking quotient rule. So if we're gonna be taking the antiderivative, we gotta kind of think along the same lines. And I don't know about you, but I don't wanna use the quotient rule yet. I'm not ready for that, not backwards. So what we're gonna make sure that we do is when we see one that looks like this, we want to do a rewrite here. So what we wanna do is, because we just have a single term on the bottom, we want to split this up into two separate fractions. So we want this to look like t squared over t squared plus 2 over t squared dt. Okay. All right, so I know it still looks ugly, but can we do a little simplifying here? So when we keep rewriting, isn't t squared over t squared just 1? So don't we have 1 plus, and could I pull these t squareds up to the top? So could I pull that up and do 2t to the negative 2 dt? Okay, so at this point, if you are given a fraction, okay, with a function on the top, you know, a rational function in top and bottom, okay, what you want to do is rewrite it. You want to rewrite it so you can get it to the point where it doesn't have a fraction in it. Now we're going to use those basic rules that we've just learned to figure this out. So 1 is just a constant. So if we want the antiderivative, we just slap the variable on it. Now don't put x, remember it's t. So this is 1t. And then we've got this plus 2. Now again, remember the exponent is going to go up by 1. Hold on one second. Pruny! 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 Hey! Hey! Dog is digging a hole in the lawn. Sorry about that. Okay, so this is going to go up by 1. So it's going to be a t to the negative 1 over negative 1. Okay. And then our plus c. And then again, we'll do a little bit of simplifying here. So we can say t, and then this is going to become minus 2t to the negative 1 plus c. So creating more of what looks like a polynomial or single terms, because that's the rule we have. We have the rule that if terms are put together with plus or minus, addition or subtraction, then we can take the antiderivative. We do not have a rule about division yet. Okay, we don't have a division or a multiplication rule. So same thing goes if we were to see something like this. Let's say we have the integral of 2x plus 7 squared dx. Okay. Now on this one, we have multiplication going on here, or we have like the chain rule idea going on here, but remember that we haven't learned anything like that. We only have the very basics to start with. So what we're going to do is actually do what this is telling us to do. We're actually going to square it out, or we're going to FOIL it. So we'll end up, when we FOIL this out, we'll have 4x squared up in the front, and then we're going to have 14x and another 14x, so we'll have 28x, and then plus 49 at the end, dx. So again, we get it into a notation that looks very similar to what our rule says. Split between addition and subtraction, whoop, and then we can find the antiderivative. Okie dokie. So we're going to start here, leave the 4x cubed over 3 plus, put the 28, x squared over 2 plus, and then remember this one, you just slap the x on there. And then again, follow it with the plus c. Then take that one last step to go through and make sure that everything is simplified. So we can change that to 14x squared plus 49x plus c. And as you get going in these, I don't need to see this step. If you can see just from looking at this that you're going to make the exponent 2 and so you need to divide by 2 and you go right to this, that's totally fine. If you're ready to do that, you go for it. If you still like to see this so that you can visualize each step, go for that. I'm not particular on that one, okay? I don't need to see that intermediate step if you don't want to. Baron, Lego. Ay, this is not the day to be doing this, okay? Okay, I got one more problem. So hopefully the dogs will lay off and we can get our one word problem out of the way. Okay, one more problem here. Okay, so this says the marginal cost of producing X units of a product is dc dx equals 32 minus 0.04x. It costs $50 to produce 1 unit. Find the cost function and what is the cost for 200 units. Okay, so two-parter on this one. Now, you got to read the problem carefully. Make sure that you understand what you've been given. So this one starts off right off the bat by saying the marginal cost. When you hear the word marginal, that's your clue derivative, right? Then even in the notation, they use the derivative notation. So they have started us with the derivative, and they want us to go back to the original. So we want to go back to the original, which means that they're asking us to find the antiderivative, aren't they? Okay, they're asking us to take that guy and go backwards or find the antiderivative. So we can say then that cost should equal, all right, let's go for this. So this is a constant, so we're just going to slap an x on it. So 32x minus 0.04x squared over 2. And then don't forget your plus c. Now we have an issue. That C stands for cost, and that C stands for constant. So this might be a time where you actually come in here and write the word cost, okay? Because we don't want to have C's all over the place, all right? That's going to be too much of a mess. So you might want to write the word out cost. Okay, now a little bit of simplifying to do right there. So cost equals 32x minus 0.02 x squared plus c. Baron! Now, in this case where we given an initial value, we were told it costs $50 to produce 1 unit. So will we be able to figure out what our constant is in this problem? We know that the cost would be $50 if x is equal to 1. So let's put that in. So $50 equals 32 times 1 minus 0.02 times 1 squared plus c. So 50 equals 32 minus 0.02 plus c. So 50 equals 31.08. And if we subtract, you know what, the old brain isn't working all that well today, so why don't we just actually use the calculator? I know, I should know how to do this, but better get it correct than have my brain screw it up. So 18.92 plus C, or equals C. See, I told you I was going to screw something up. All right, so we now have the actual cost function. So the cost function, again, I'm writing it out in words there, is 32x minus 0.02x squared plus 18.92. So that is the actual cost function for our product. We found that. Then it also asks us, what is the cost when we want to produce 200 units? So now that we have the actual function, could we plug 200 in there and see what pops out? Okay, so we'll say cost equals 32 times 200 minus 0.02 times 200 squared plus 18.92. Okay, this one I'm most definitely using my calculator. Minus 0.02 times 200 squared plus 18.92. All right, and I got a cost of $5,618.92. All right, what do you think of that? Well, good. Okay. All right, so we did word problem, and the word problem had that initial value in it. Okay, so those initial value problems are definitely important. Okay. All right. Now, what was I going to say? Oh my God, I'm standing here looking at this and I can see a mistake. What a moron. Sorry everyone. Sorry. 32 minus 0.02. See, I should use my calculator for that one too. How about 9/8? So that's going to be a 0. 0, 0. And I'm going to have to put that in my calculator again. 0, 2, 0, 2. Okay, one more time. Sorry. 32 times 200 minus 0.02 times 200 squared plus 18.02. Okay, how about this? 5,618.02. Okay, so apologize for that. I don't know. You know, some days you're on, some days you're not. I don't know, is it because it's cold? Who knows? Okay, so I apologize. This has been kind of an up and down lecture, and obviously interruptions by dogs and phone calls and everything. So yeah, that's just the way life goes when you're trying to do this stuff from home. Okay. Someone wants to say goodbye to you though. He's been a very good boy today and hasn't been annoying anybody, so he thought he'd come and say goodbye. So Handsome, say goodbye to everybody. You're on camera, Handsome. Whoa, you scared? Oh, Handsome is shy. Okay, say goodbye to everybody, Handsome. Alrighty. Okay, everybody have a good day. I'll see you next time.